Okay, Jennifer said forgot what it's called, but they have to be split into two different parentheses. Well, if it's factorable, yeah. If it's factorable, you're absolutely right. If what we have at the top of the fraction is factorable, you factor it, and then you hope to reduce x minus 3. But this is not factorable. When you cannot factor it, then you have to use long division to do this. So what you need to do is to write down x to the power of 2 minus x plus 13 and divide x minus 3 into that this way. Long division. Okay. So when we do this, the first step would be to see what times x give you x to the power of 2. Make sure these are in the right order, in standard form. So first is x to the power of 2, and then it's x, and then constant. If they are given to you in different order, make sure you write it in the right order. So what times x give you x to the power of 2? Okay, those of you with the microphone, you can respond or just type your answer.
X.
Okay, Daniel says x. That's correct. So if I put x here, x times x give you x to the power of 2. And then what do we have to do next? What do we have to do with this x? Okay, then you put Renee says multiplied by negative 3. We have to distribute this x by x minus 3. So it would be x times x would be x squared, x times negative 3 then would be negative 3x. Now to find the remainder, we need to subtract, right? This is plus. So we need to subtract this to find the remainder. Can somebody tell me what would be the remainder? Okay, to subtract, you have to change the subtraction to addition and change the sign of the second row into its opposite sign. This becomes minus, this becomes plus, and then just simply add these two rows together. Okay.
The answer is positive 2 plus 13.
Okay, very good. Jennifer just typed, why did you put a plus sign next to x to the power of 2? Well, because x times x is x to the power of 2. I put a plus sign here to remind you that the sign for x to the power of 2 is positive. So when I subtract this row from this row, I need to change the sign from subtraction to addition. Now I have to change the sign of each sign in the second row into its opposite sign. So this was plus before, now it become minus. This was minus, now it becomes plus. So now I can add these two. So x to the power of 2 minus x to the power of 2, that adds up to 0. So here, as Danielle says, negative x plus 3x, that gives you a total of 2x plus 13. So that would be my remainder so far. Remember, when you subtract in columns, you change the subtraction to addition, and then change the sign of the second polynomials into its opposite sign. This is just really is like when we say we have x to the power of 2 minus x plus 13 minus x to the power of 2 minus 3x. That's what we're really doing. We're subtracting these polynomials to find the remainder. You see, we're keeping the top one as is, and then we're changing the subtraction to addition and change the sign of the second one into its opposite sign. We just add this polynomial. In other words, what we're doing really is we're distributing this minus here. See, minus 1 times x to the power of 2 becomes minus x to the power of 2. Minus times minus becomes plus 3x. However you look at this, then you would get the same answer. So this would be minus x squared. If I remove the parentheses, that's what we have, right? So we would get in this case, we get 3x minus 1x give you 2x plus 13. As you see, these two reduces to 1, reduces to 0 actually. Plus x squared minus x squared will add up to 0. Can I see a check mark in front of your name if you follow this up to this point, if you understand how to find this remainder so far? Good. Okay, what would be the next step? What are we going to put here? How do we continue? What times x give you 2x? Okay, Danielle, what do you think?
I think 2.
Right, that would be plus 2. So now I need to distribute 2. Okay, so now it's like I have 2 times x minus 3. I distribute the 2 to place it here. So that becomes, again, plus 2x minus 6. Now to find the remainder, we do the same again. We change the subtraction to addition and change the sign to its opposite sign, and we add. So this times 2x and minus 2x adds up to 0. So can you all tell me what is the remainder?
19.
Jennifer, do you see that? 19. All right. What would be the next step? Now we have a remainder. When we have a remainder, we have to ask ourselves, what times x minus 3 give me 19? That would be a fraction. Can somebody tell me what do I have to put at the top and bottom of the fraction here to get 19? Jennifer said the top I have to put 19. Yes. Always the number at the top of the fraction would be the remainder. What are we going to put at the bottom of the fraction? Danielle?
The x minus 3.
Right, x minus 3. Because we want to reduce that. So if I multiply 19 over x minus 3 by x minus 3, x minus 3 cancels and I get 19 here. And then Now, if I subtract, the remainder would be 0. So when you see a fraction here, that's all it means. You have a remainder, and the number at the top of the fraction is the remainder. So when you divide by more than one term, like binomial in this case, then you have to set up the long division. If you are dividing by monomial, one-term polynomial, you separate them. You have to know the difference between these two.